Welcome to our DIY robotics workshop, where today, we'll guide you through the process of creating your very own robotic arm. Whether you're a hobbyist, student, or aspiring engineer, building a robotic arm can be an exciting and rewarding project. Imagine having a robotic assistant capable of picking and placing objects, performing assembly tasks, or even assisting with scientific experiments. That's the potential of a well-designed robotic arm. Let's dive into the steps involved in creating your robotic arm. First, you'll need to plan and design your robotic arm structure and functionality. Next, select the necessary components, such as motors, sensors, and controllers. Mechanical components, structural elements, aluminum or steel bars, rods, or plates to form the arm's frame and links. Joints, servo motors, stepper motors, or DC motors with gears to provide rotation at each joint. Gripper or end effector, mechanical or pneumatic grippers, suction cups, or specialized tools for grasping and manipulating objects. Electrical components, motors, servo motors, stepper motors, or DC motors to actuate the joints and control the movement of the robotic arm. Motor drivers, electronic circuits or modules to control the speed and direction of the motors. Sensors, position sensors, potentiometers, encoders, force sensors, or proximity sensors to provide feedback on the arm's position and interactions with the environment. Power supply, batteries, DC power adapters, or motor drivers to provide electrical power to the motors and control circuitry. Electronic components, microcontroller, Arduino, Raspberry Pi, or other microcontrollers to control the robotic arm's movements and interface with sensors and actuators. Motor controllers, H-bridge motor drivers, motor driver shields, or motor controller boards to drive and control the motors. Interface components, buttons, switches, potentiometers, or joysticks for manual control or user input. Control components, control algorithms, software algorithms to interpret sensor feedback, generate motion trajectories, and control the robotic arm's movements. Programming languages, C++, Python, or other programming languages to develop control software for the microcontroller. Control interfaces, graphical user interfaces, GUIs, command line interfaces, CLIs, or mobile apps for controlling the robotic arm remotely or setting parameters. Structural components, mounting hardware, bolts, screws, nuts, and brackets to assemble the mechanical structure and mount components securely. Bearings, ball bearings, bushings, or linear bearings to reduce friction and provide smooth movement at joints and linkages. Optional components, communication modules, Bluetooth, Wi-Fi, or Zigbee modules for wireless communication between the robotic arm and external devices. Vision systems, cameras, depth sensors, or LiDAR sensors for visual feedback and object recognition. Additional actuators, pneumatic cylinders, linear actuators, or hydraulic actuators for specialized applications requiring high force or precision. These will form the backbone of your robotic arm. Once you've gathered your components, it's time to start building. Assemble the mechanical structure of your robotic arm, ensuring smooth movement and precision. With the mechanical structure in place, it's time to wire up the electronics and program the control system. This will allow your robotic arm to move and perform tasks autonomously. After testing and calibration, you can integrate an end effector, such as a gripper or tool, to complete your robotic arm. Document your progress, including the design, construction process, and programming code. Sharing your project online can inspire others and contribute to the DIY robotics community. Once your robotic arm is complete, the possibilities are endless. You can use it for tasks like assembling small electronics, sorting objects in a warehouse, or even assisting with scientific research. And there you have it, your very own DIY robotic arm. Whether you're exploring robotics as a hobby or pursuing it as a career, building a robotic arm is a fantastic way to learn and innovate. So, roll up your sleeves, gather your tools, and let's bring your robotic arm project to life. Thank you for watching this video, and if you like this button, please give it a thumbs up.